Okay, as promised, we're going to do some examples of some inequalities. So first one, let's start off with, let me make sure I'm in the right color here. I'm in red. Let's try black. So number one, let's try x times x plus 3, come on, times x minus 1 is greater than 0. So where is this statement going to be true? Well, we're lucky in the sense that this thing is all nice and factored out for us, right? We can get x equals 0, x equals negative 3, and x equals 1. If we were just going to graph this polynomial, we would say, okay, I know this is third degree polynomial. This is going to look like this, and this is going to look like this at the top. All right. I know that there's an intercept at 0, there's one at 1, 2, at negative 3, and there's one at 1. So I know it's going to look something like this, and I know it's going to go up and down like this, right? So now the question asks, when is this function greater than 0? Well, it's greater than 0 here and here, right? So that means it is greater than 0 in between 2 points, between negative 3 and 0, and when it is greater than 1. So the solution to this inequality is easily seen from the graph. The solution would be the set of x between negative 3 and 0 and between 1 and positive infinity. Let's do another one. These are kind of squirrely. We should make sure that we understand them. Okay. How about, let's do, oh, in red. Switching back to black. Let's say, what happens if 3x squared is greater than x plus 2? So what we really want to know is when is the parabola 3x squared greater than the line x plus 2? But what we can do is we can solve this thing, right? We can say this is 3x squared minus x minus 2 is greater than 0. So now we can factor, right? Got a 3x and an x. Got a 2 and a 1. Put the 2 over here because I knew I was trying to get to just 1x. We have 3x. We need it to be negative. So we need a negative 3x plus a positive 2x. So we end up with x equals negative 2/3 or x equals 1. Now, if we were to graph this quadratic, we would say, okay, at negative, we have an x-intercept at negative 2/3, we have an x-intercept at 1. So our function looks something like this. Now, we want to know, when is our function greater than 0? Well, it's greater than 0 here, and it's greater than 0 here. So that means from negative infinity all the way to negative 2/3, and from 1 on to infinity, oh, sorry, this should be a rounded bracket, right? Because the infinities always get rounded brackets. So our function, the statement is true when x is in between negative infinity and negative 2/3, or when it is between 1 and positive infinity. This is a little way to show you that when you actually graph a function, you can use it to solve what otherwise might be kind of confusing inequalities.